Remember those PCBs we designed, ordered, and hyped up? Well, they're here fresh out of the oven, looking fly in that sleek black and gold ENIG finish, basically the Rolls-Royce of PCB finishes. Today, we're unboxing, assembling, and programming this bad boy to light up like a mini rave party in your living room. Oh, and did I mention? We're also throwing in a slick acrylic case to make this cube not just a tech masterpiece, but an absolute vibe. Let's get building because this thing is about to shine brighter than a supernova on a Saturday night. Let's go. Step 7: PCB manufacturing and assembly. After completing the payment process, skilled engineers at JLC PCB conducted a DFM analysis, corrected parts placement, and confirmed that our design could be successfully manufactured. This standard procedure ensures a smooth production process. Once the analysis was complete, the PCB manufacturing process began. Let me walk you through the magic that happens behind the scenes during PCB manufacturing. Here are the stages of PCB manufacturing. I plan to create a detailed video on this process. Let me know in the comments if you'd like to see it. After production, the finished PCBs were sent for assembly. Here are the stages of PCB assembly. Once assembly was complete, the PCB and PCBA were securely packaged and shipped via the chosen delivery partner. The parcel was delivered to me in just 9 days. JLC PCB achieved this remarkable turnaround by completing the entire process, including PCB manufacturing, sourcing components, a 48-hour component baking process, and assembly within 7 days. The package spent only 2 days in transit. This efficiency was aided by completing the KYC process before the parcel landed in India, which minimized customs clearance time. The package was at my doorstep the next day. Step 8: PCB and PCBA unboxing and review. The PCBs arrived on time and exceeded my expectations in quality. The black finish with ENIG plating gave them a premium appearance, so good it feels like unwrapping a designer gadget. The precisely drilled castellated holes ensured easy assembly. The silk screen was sharp and clear with no smudges or errors. Wires were perfectly aligned, ensuring excellent heat dissipation. Overall, the manufacturing was flawless. I'm thrilled with the results. The assembled PCBs were equally impressive. Components were perfectly placed and soldered, with the WS2812C LEDs securely mounted and free of visible defects. Every part was tested and fully functional out of the box, making the process seamless. Now for the fun bit, getting our ESP8266 module into action. I prepared for this by removing the headers, placing the ESP8266 module, and soldering it into position. Before we dive into the programming chaos, quick throwback to part 1. True to my word, I've uploaded every single detail, schematics, layouts, Gerber files into Altium 365. This cloud platform isn't just for me to share, it's for you to download, review, and even tweak for your own projects. And yes, I skipped adding my logo to the files so you can download, print, and make this project your own. No strings attached. Here's the coolest part. Altium 365 doesn't lock you into one tool. Whether you're a fan of Eagle, KiCad, or even OrCAD, you can easily connect your ECAD tool and collaborate. Plus, it's free. Yep, free to sign up and use. Oh, and if you're a newbie, Altium's Student Lab offers this dope course, Learn Printed Circuit Board Design. From schematics to manufacturing, it's like a masterclass but totally free. I've linked everything, including the course and my project files, down in the description. So yeah, designing that flawless PCB you just saw. Altium 365 had my back, and now it can have yours too. Definitely check it out. Step 9: Programming the ESP8266. Alright, soldering done. Time to fire up the ESP8266 and get to programming magic. I connected the module to a computer for programming. Using ESP Home Flasher software and the WLED ESP8266 bin file, I successfully programmed the module. The ESP8266 booted up with an orange light. Initially, only 30 LEDs were lit due to the default configuration. By updating the LED count setting from 30 to 36, the remaining LEDs also lit up as expected. For a detailed walkthrough of the programming process, check out my video How to Make Iron Man Arc Reactor Part 2, linked in the description. It covers everything related to programming step by step and packed with tips to make programming this bad boy a breeze. Now, let's move on to assembling this beauty into its glowing final form. Step 10. Building the cube. With the PCB functioning perfectly, the next step was assembling the PCBs into a cube. First, I removed the assembly rails to prepare the PCBs for joining and soldering. To control all 216 LEDs using a single data line, I connected the data output line of one LED to the data input of the next. Similarly, the data output of one PCB was connected to the data input of the next PCB along with the power rails, 5 volts and ground. Each PCB was designed with 2 data inputs and 2 data outputs for seamless connectivity, a feature carefully planned during the schematic and layout stages. I then soldered a second set of PCBs in the same way, ensuring the power rails were also connected. Once both sets were ready, I joined them together as shown, creating the 4 side faces of the cube. After that, I placed the top face and soldered it securely. A minor challenge. The last PCB lacked a direct data connection to adjacent PCBs as their input and output lines were already coupled. Connecting to any of these would disrupt the sequence. To resolve this, I pulled a wire from the last PCB to ensure it received input from the preceding PCB while maintaining the correct sequence. Next, I connected the 5 volts and ground lines to adjacent PCBs since no sequencing is needed for power rails. Once all 6 PCBs were soldered, I connected the input power wires and powered up the cube with 5 volts. The ESP8266 booted up and one PCB lit up with an orange light. The rest of the LEDs lit randomly due to the default WLED configuration of 36 LEDs. Updating the LED count setting to 216 resolved the issue, lighting up all the LEDs as expected. Step 11. Designing and assembling the acrylic casing. To showcase the cube's mesmerizing light patterns, I designed a casing to enhance its aesthetics and protect the PCBs and LEDs. The casing consists of 6 interlocking faces, laser cut from 3 mm white acrylic. Here's a cool fact. Laser cutting uses a focused beam of light to melt, burn, or vaporize material with precision. For acrylic, the laser creates smooth, polished edges that require no additional finishing, perfect for achieving a clean, professional look. It's like crafting with light. After the laser cutting process, I peeled off the protective film from each acrylic piece and arranged them for assembly. Using tape to temporarily hold the faces together, I applied super glue to secure the edges. Once the edges were fixed, I soldered the power cables for 5 volts and ground. Next, I carefully slid the cube into the acrylic casing, routing the power cables through before placing the final face. I secured the bottom face with super glue and repeated the process for all other outer edges to ensure a sturdy and polished finish. I removed the remaining protective film to reveal the clean, smooth texture of the acrylic casing. Step 12. The insane LED cube demo. The LED cube is finally complete. Connect to the WLEDAP Wi-Fi network from your phone, log in and access the controls to customize the cube's colors and patterns to your heart's content. Just take a look at some of the stunning colors here. Fun fact, this cube can produce an astonishing 16.8 million colors. You may ask how. The red, green and blue LEDs within each WS2812 have 256 brightness levels. When multiplied, red 256, green 256, blue 256, you get 16,777,216 unique color combinations. But that's not all. This cube isn't just about colors. You can explore a variety of patterns and effects. Here's a demonstration showcasing its dynamic color transitions, pulsating effects, and synchronized patterns. Each effect highlights the cube's versatility and precision, making it an absolute showstopper. Summary and wrap up. This LED cube is a stunning example of how creativity and engineering come together. Whether as a personal project or a creative showcase, it's a testament to the power of DIY electronics. Got ideas for your own LED cube or questions about the build? Drop them in the comments. I'd love to hear from you. Stay tuned for more exciting creations. Bye bye.